All right, let's take a look at a second example. So the position of a particle moving on a line is given by the equation S, which tells us the position, is a function of time that is equal to 2t cubed minus 21t squared plus 60t, where once again, t has to be greater than or equal to 0. So we know that t once again has to be positive. T is measured in seconds and S is measured in meters. The first question that asks is find the velocity of the particle after 3 seconds and after 6 seconds. Well, we already know that when we're looking at velocity, velocity is the first derivative of that function. So if f of t is equal to 2t cubed minus 21t squared plus 60t, then that means that the velocity is going to be f prime of t, which is going to equal 6t squared minus 42t plus 60. So if I'm trying to solve it at 3 seconds, then I'm just going to take v at 3 is equal to 6 times 3 squared minus 42 times 3 plus 60. And then I can plug all that in and I get negative 12 meters per second. If I take the velocity at 6 seconds, then it's going to be 6 times 6 squared minus 42 times 6 plus 60, and that's going to give me 24 meters per second. So at one point for 3, it is moving in a negative direction, and at one point for 24, it's moving in a positive direction. When it says, when is the particle at rest? Well, at rest is a fancy way of saying the velocity is equal to 0. When it says when, we're just trying to solve what the time is. So I'm going to say that given this problem, that v of t, which we already know is equal to 6t squared minus 42t plus 60 has to equal 0. I'm just going to solve this by factoring. So the first thing is I'm going to divide both sides by 6 to get t squared minus 7t plus 10 is equal to 0. I'm going to factor this to get t minus 2 and t minus 5 is equal to 0. And if t minus 2 and t minus 5 are equal to 0, then t is either equal to 2 or 5. Now, those both fit into the t is greater than or equal to 0, so those both work. And I'm just going to state that the particle is at rest at 2 seconds and 5 seconds. When it says, when is the particle moving in a positive direction? Well, a positive direction is just the same as stating that the velocity is greater than 0, or that 6t squared minus 42t plus 60 has to be greater than 0. Now, we learned how to solve inequalities all the way back in grade 11. We can algebraically approach this by doing sign analysis, case analysis, or interval study. Or we can do this graphically. So just for the sake of time, I'm going to do this graphically, and I know that I have a quadratic. That quadratic has a positive a value, so it's going to be moving upwards. And it has x-intercepts that we already solved from the previous case, or the previous example, at 2 and at 5. Now, we know and we can tell that from this, there's going to be two sections. There's going to be the section when the velocity is greater than 0, and there's going to be the section where the velocity is less than 0. So from this, I can tell that the velocity is greater than 0 here and here. So I'm going to state that on the right-hand side, the velocity is going to be greater than 0 when t is greater than 5. Anytime that t is greater than 5, the velocity is greater than 0. For this section here, I can see that the velocity is greater than 0 when t is less than 2. And the only thing you need to remember from the original question, if we scroll back real quick, is that t has to be greater than or equal to 0. So even though I don't see it on the graph here, I know that the lower end of this has to be 0. So I can state that that's a range, or I can state that t is an element of 0 to 2, or 5 to infinity seconds. Both work. Now part D is the part that more people struggle with. It says find the total distance traveled by the particle during the first 6 seconds, which means that it's going from 0 for t all the way up to 6 for t. Now, when we're doing this, anytime we're looking at the total distance, we're looking at the absolute value of the sum of the differences, which means that I can look at it two ways, and I don't really care which method you prefer. I can say that it's going to start at 0, and it's going to increase, so it's going to move to the right for the first 2 seconds, and we know that because in the last question we solved that it was positive for the first 2 seconds. And then after the first 2 seconds, it's going to decrease or have a negative velocity up to 5 seconds, and then it's going to increase again in that last section between 5 and 6 seconds. If it is easier for you to understand vertically, and that's perfectly fine, then we would draw it that way. We would say that it's going to start at 0, and then it's going to go up to 2 seconds, and then it's going to go down to 5 seconds, and then it's going to go up again for that last second. It doesn't really matter which of these two you prefer. I find that a lot of people find it easier to think of it as up and down, which we always think of as positive and negative, as opposed to left and right, which sometimes we don't think of as positive and negative. So what am I going to say? I'm going to say that the total distance is going to equal the same as the absolute value of the first 2 seconds change in displacement from where I started. I'm going to combine that with when it moved in the negative direction, how much distance changed in the next 3 seconds, or between 5 seconds and 2 seconds. And then finally, I'm going to combine that with the absolute value of f6 minus f5. Remembering that each of these is how much change in distance or displacement occurred in between those time increments. And this is always based on going from positive velocity to negative velocity to positive velocity again, and back and forth, however many times you'd have to do it. Now, when we're doing this, remember that this is based on your original equation. So I'm saying that the total distance is going to be f of 2, which we know is 2 times 2 cubed minus 21 times 2 squared plus 60 times 2 minus f of 0. Well, at 0, no change has taken place. I'm going to combine that with the displacement at 5 seconds. So 2 times 5 cubed minus 21 times 5 squared plus 60 times 5 minus whatever the f of 2 winds up equaling. And then finally, I think I'm going to run out of space here, I'm going to take the 2 times 6 cubed minus 21 times 6 plus 60 times 6 minus whatever that f of 5 was. And remember, when you're doing this, you can just put it in once. If this is what f of 2 is, you don't have to write it out twice. You can just state that you're taking away that f of 2 once you solved it. And then I can do the same thing here, where I'm saying this is f of 5, and then this is f of 5. When I simplify it, I get 52 minus 0 plus the absolute value of 25 minus 52 plus the absolute value of 36 minus 25. And that's going to give me the absolute value of 52 plus the absolute value of negative 27 plus the absolute value of 11, or 52 plus 27 plus 11, which means that the total displacement is 90 meters.